And on exponential equations, there are some keys here. I need to know how to solve an equation where I have either like bases or unlike bases with an x in the exponent. So I have an exponential equation here. The key is I want the bases to be the same, and I want these two things to be the same, right? Because if I had 2 to the 5th equals 2 to the 5th, I know that's true. It's the same, right? 2 to the 5th has to equal 2 to the 5th. Well, if I said 2 to the 5th equals 2 to the x, I know what x has to be to make those two things the same. X would have to be 5, would be 2 to the 5th. So instead of 2 to the x, I would just have x equals 5, and I would be done. So with that knowledge, I can take any exponential equation with the same base, and as long as they have the same base, you can ignore the bases. I shouldn't use x. You can ignore the bases and just write the equation 5 equals x and solve. Well, in this case, we have 5 equals x plus 1. And as long as those are the same, then I have equivalent parts on the left and right side. I have a true statement. So here I have x plus 1 equals 5. If I subtract 1, x would equal 4. And let's check our work. If I were to substitute 4 in for x, what would I get? 2 to the 5th equals 2 to the 4 plus 1. Well, I know that's true because if I were to simplify this side, 4 plus 1 is 5. 2 to the 5th has to equal 2 to the 5th. So that must work. We can do the same thing here with the number 2. I have like bases. So I see 6 to the 2x equals 6 to the 6th. Well, if these are the same base, I don't really need the base. I can say 2x equals 6 and divide to get x equals 3. Why don't you take a second, pause the video, and try number 3 and check your work. Alright, so hopefully you've paused the video, tried it, and then you're coming back right now to check your work. This equation would be 2x minus 7 equals 3x plus 4. So in this problem, we're going to get a negative number, and that's okay. So if I were to solve this, I would get 1x equals negative 11, or x equals negative 11. Now what's weird is when I get to something like 4, 5, and 6. So on 4, 5, and 6, I have an extra step to do. Here I have a power to a power. Let's recall that if I had like x to the 3rd to the 2nd, I see parentheses, that means I need to multiply those exponents, and I would get x to the 6th. In the same way that we did that earlier, I'm going to end up with a distribution problem here. I get 4 to the 2x plus 2. And now check it out. We have the like bases again. There we go. Those are our like bases. And that means that I can just get rid of the bases and solve this 10 equals 2x plus 2. Or if I solve, x would equal 4. But I still had like bases. Let's see what happens when I have unlike bases. This is 1/2 to the 3rd. Okay, we have to do a little bit of review here. 2 to the 1st is 2. 2 squared is 4. 2 to the 3rd is 8, and so on. But 2 to the 0 is 1, and this is where it gets weird. 2 to the negative 1st is 1 over 2. Why does that happen? Because anytime you have that negative exponent, you have to change the side of the fraction that power is on. So here I had 2 to the first over 1. Well, I have to flip that from the numerator down to the denominator to make that no longer a negative. So instead of 1/2, 1/2 is really 2 to the negative first power. I'll keep that 3 equals 2 to the 3x. So all we did here was we changed 1/2 to 2 to the negative first, but they mean the same thing. So now what we can do is we can write this as, if I multiply, I get 2 to the negative third power equals 2 to the 3x. And it's very tempting to want to rewrite this as 1 over 2 to the third equals 2 to the 3x. But remember what our goal is here. We want like bases. This is not like bases anymore. So even though it is very tempting to rewrite it, let's leave it in this format because now my bases are 2 and 2. They're the same. And I can ignore those bases and get negative 3 equals negative 3x, or x equals negative 1. Remember, the key is to get the same base. Check this one out. I've got 1/8 and 8. Well, how can I rewrite 1/8? Instead of 1 over 8, let me think of this as 8 to the negative first power. It means the same thing as 1/8. Okay, I'm going to take that 1/8 and bring down the x minus 4 equals 8 to the 4x plus 1. Now please notice that you have to distribute both parts here, multiply that negative 1 to both parts, and then you have like bases so you can solve. I would encourage you to pause this problem, try it on your own, and then unpause and check your work. All right, I'm going to use black just to avoid any red-green issues here. So this would be 8 to the negative x plus 4. Remember, negative times negative equals a positive 4 there. Equals 8 to the 4x plus 1. So I get negative x plus 4 equals 4x plus 1. And if I solve, I get 3 equals 5x, or x equals 3/5. All right, so let me know what other questions you've got there. Check out our last couple questions at the start of class tomorrow, and then I will see you then.